And good morning again. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I will respond as soon as I can. All right, this morning I've got some questions from a couple of students from section 5.6. So we're going to start by looking at those. So this is from section 5.6, problem number 14. And as I say, everyone has a similar problem, but your numbers may be different. Anyway, problem number 14, it says this. It says, multiply, simplify your answer completely. And it has negative 8r times the quantity r plus s times the quantity r plus s. So we're going to start by multiplying the first two factors together. And so we'll distribute the negative 8r. So we get negative 8r squared minus 8rs. And then that quantity will get multiplied by the quantity r plus s. Any questions so far? All right, then we'll continue and we'll take negative 8r squared times r, which is negative 8r cubed. Then we'll take negative 8r squared times s, which is negative 8r squared s. Next, negative 8rs times r, which is negative 8r squared s. And then negative 8rs times s, which is negative 8 or minus 8rs squared. Notice that within each term, I put the variables in alphabetical order. That makes it easier to identify like terms. These two terms in the middle are like terms. So we end up with negative 8r cubed minus 16r squared s minus 8r s squared. And there's the final answer. Any questions on that? Okay, moving on. Next, in that same section, we have problem number 23. It has two parts. Part A, we are to add 1/3 c minus 3d plus the quantity 5/6 c plus d. All right, so we're adding here. We're not multiplying. Since there's nothing in front of the first set of parentheses and a plus sign in front of the second set, we're going to just bring down 1/3 c minus 3d plus 5/6 c plus d. Well, to combine like terms, these are like terms and those are like terms. But to combine these, we need a common denominator. So if we've got 1/3 c plus 5/6 c minus 3d plus d, the common denominator here of 3 and 6 would be 6. So 1/3 c needs to be something over 6c plus 5/6 c would still remain 5/6 c because it already has the common denominator. I need to convert 1/3 into something over 6. So I'm going to multiply by 2 over 2. So 2 over 2 times 1/3 becomes 2/6. So 1/3 gets built up to 2/6. Now I have the common denominator and I can add 2/6 plus 5/6 is 7/6 c. And then minus 3d plus d would be minus 2d. So here is the answer to 23 part A. Let's see if we can fit part B in here. Part B is, where did it go? It's the same two polynomials, but now instead of adding them, we are going to multiply them. So 1/3 C times 5/6 C, 1/3 C times 5/6 C plus 1/3 CD minus 3D times 5/6 C minus 3D squared. Okay. That first one, let's see, that's going to be 5/18 C squared plus 1/3 CD. Let's see, I've got minus 3D times 5/6 C. The 3 and the 6 reduces to 1/2. So I've got minus 5/2 CD minus 3D squared. Any questions so far? But now I need to combine these two like terms. The least common denominator of 3 and 2 would be 6. So this becomes 5/18 C squared plus so many 6ths CD minus so many 6ths CD minus 3D squared. I need to change 1/3 into something over 6. If I multiply the denominator by 2, I get a 6 in the denominator, but then I need to multiply the numerator by 2 as well. So I'm going to take 1/3 CD, multiply it by 2/2, and get 2/6 CD. Then I've got minus 5/2 CD, and I need to change that 2 into a 6. So I'll multiply the denominator by 3, which means I multiply the numerator by 3, and I get 5/2 becomes 15/6. Well, finally, I've got 5/18 C squared. 2/6 CD minus 15/6 CD would be minus 13/6 CD, and then minus 3D squared. And I can't simplify any of those further. I can change the minus 13/6 to a mixed number, but we don't tend to use mixed number coefficients with variables. It isn't wrong, we just don't tend to do it. All right, that's problem number 23. Any questions there before we go on to the next problem? Okay, let's do that. Coming up next is number 26, and I want to go to the picture in WebAssign. Says find the polynomial that represents the volume within the batting cage. So we've got this it's kind of a rectangular shaped, it's like a shoebox kind of thing. Okay, and we're given the dimensions, and then we're told that A is 1, B is 4, and C is 2. Now, to find the volume of a solid, it's not really a solid, but a box like this, the volume would be the length times the width times the height. Okay, now if the volume equals the length times the width times the height, let's see, the length, I'm going to call this the length 5x plus b, but b is 4. So the length would be 5x plus 4 feet. All right. If this is the length, this will be the width, which is 3x plus a, but a is 1. So the width is 3x plus 1 feet. And finally, the height, 3x minus c feet, where c is 2. So the height would be 3x minus 2 feet. So the length is 5x plus 4 feet. The width is 3x plus 1 feet, and the height is 3x minus 2 feet. Now, I said volume was length times width times height. So the volume is going to be 5x plus 4 times 3x plus 1 times 3x minus 2. And then we'd have feet times feet times feet. So our final answer is going to be so many cubic feet, but we'll get to the cubic feet here eventually. So I'm going to multiply the first two together. I'll FOIL those together and I'll get 15x squared plus 15x plus 12x plus 4, which simplifies into 15x squared plus 27x plus 4. So all of that is going to get multiplied by, whoops, not plus, but minus, by 3x minus 2. Okay. And again, this is going to be cubic feet. So now I'm going to take 15x squared times 3x, which is 45x cubed. 15x squared times minus 2, which is minus 30x squared. 27x times 3, which is going to be what? 81x squared. 27x times minus 2 would be minus 54x. And then 4 times 3x plus 12x, 4 times negative 2 minus 8. So I've got all of that, cubic feet. Combining like terms, we get 45x cubed plus 51x squared minus 42x. Let's see. Minus 8. I think I've done something wrong here.
Wouldn't the 15x be 5x instead? Because it's 5x times 1
Yes.
at the very top.
The very top.
Instead of, so it's 15x squared plus 15x, but shouldn't the 15x be 5x?
Oh, I see. Yes. So I must have read this as a 15. That's my excuse anyway. Thank you. Thank you. Yep. Too much of a hurry. So then that makes this, don't panic, we can solve this 17. Yeah, that's going to change everything, isn't it? I'm going to panic instead, and I'm going to go back and I'm going to fix this. Yeah, that's what I get for, I think I read that parentheses out in front as a 1 instead of parentheses. So let's fix this. Okay. And that's going to be, that's a parentheses. Okay, let's try this again, see if I can get it right this time. 5x times 3x is 15x squared. 5x times 1 is 5x. There we go. 4 times 3x is 12x. 4 times 1 is 4. That becomes 15x squared plus 17x plus 4, all times 3x minus 2. I think we're doing better now. That's going to be 45x cubed minus 30x squared plus 51x squared minus 34x plus 12x minus 8. So let's see, 45x cubed minus 21x squared minus 22x minus 8. There we go. Thank you for finding my mistake. So there's the correct answer. And again, be careful. That's what I get for having sloppy writing. All right. I have some other questions from another student. So give me just a minute here. Let's see here. Okay. Let's see, 47, 75. Yeah. 6.
And the last one, wouldn't it be 4 or am I wrong? Because it'll be 12. Oh, never mind. That's 12x. Never mind.
Yeah, you can't, you're talking about this right here.
Yeah.
Yeah, you see, you can't read my writing either.
Thank you.
Yeah. Okay, let's see here. Here we go. Okay. So this is still in section 5.6, but this is a different student's problems. This is number 11. It says multiply, and we have 2t plus 4s times 4t minus s. So we're going to multiply those two binomials together. Okay, so we're going to get, let's see. I guess I was sharing my screen already, wasn't I? Just wanted to make sure. So this is 8t squared minus 2st plus 16st minus 4s squared. Combining like terms, we get 8t squared plus 14st minus 4s squared. Let's see here. Okay, any questions there? Next, we're going to look at number 25, and I'm going to refer to WebAssign on that. So we'll go back here, and we have problem number 25, and it looks like the things that we need to do are just the bottom part B. It says find the length and width of the garden. Okay, now let's see what we've got here. Let's call the horizontal distance the length and the vertical distance the width. Okay, now, so we've got what? X feet plus A feet. A is what? 6. So we've got X plus 6. So the length is X plus 6 feet. Now, if this is the width, this would be X feet plus B feet. B is 7. So the width is X plus 7 feet. Now, you can see the WebAssign thing, right?
Yeah.
Notice down here, the answers I wrote are backwards from what they've got. And this isn't something that's going to be a trick question on a test, but there isn't agreement within the mathematical community as to what the length is and what the width is. Some people would say the length is the longest side, which would be the X plus 7. Others say the length is the horizontal side. On this particular problem, basically what I would have to do is I would put these answers in, and then when they were marked wrong, I'd go back and switch them and say, oh, they must have called the length X plus 7 feet and the width X plus 6 feet. Okay, so that's, there wouldn't be any way of knowing. It wouldn't be a fair question for me to say, okay, what is the length without it being labeled as such? Because some of you might think it was the horizontal and some the vertical. Okay, so trial and error, I'd get there. But now, one thing that would be the same, it says multiply your answers to find the total area. Regardless of which one is the length and which one is the width, to find the total area, you would multiply them together, okay? Which is going to give you x squared plus 6x plus 7x plus 42, which is x squared plus 13x plus 42, and the units would be square feet. Okay. Now, this student also asked for number 26, but it's basically the same problem as before, just different numbers plugged in. So I'm not going to do that one. If the person that asked for that still needs it, email me and I'll or come to my office hour, and either way I'll work it out for you. All right. So now we're going to go on ahead to section 5.7. And this is called special products. So what we're going to do, it's going to be kind of like it was yesterday, where we're foiling together binomials or trinomials, but things are going to be written a little bit differently. Okay. First of all, I want to go back and review some rules that are at the beginning of this chapter. We didn't cover them this quarter. They are Math 85 topics. So they would have been covered in Math 85 or maybe in an elementary algebra course somewhere else. But one of the rules says this: if you have a product, let's say A times B, and it is, the whole thing is raised to a power, let's say n. So we have a product raised to a power. We take that power and attach it to each factor inside. So we get a to the n power times b to the n power. For instance, let's say I have 2x, the quantity cubed. This would be 2 cubed x cubed, which further simplified would be 8x cubed. Or if I had 4y to the, let's see, second power, this would be 4 squared y squared, or 16y squared. All right. Now, we've got that rule when we have a product raised to a power. What we're going to be looking at today is where we have a sum or a difference raised to a power. Let's say we've got y plus 7, the quantity squared. This is not equal to y squared plus 7 squared. That is the common mistake. It doesn't work because we're adding or subtracting. We are not multiplying. What we have to do with this is we get y plus 7 times y plus 7, which is y squared plus 7y plus 7y plus 49, or y squared plus 14y plus 49. Let's go back for a minute to this last example, and let's look at it a slightly different way. Let's see here. Lovely eraser, so efficient. All right, 2x, the quantity cubed, is equal to 2x times 2x times 2x, all right? So we have 3 factors of 2x, but it's 2 times x. It's not 2 plus x. We could rearrange this, move all the factors around, and come up with this. But we don't bother. We just apply it to both factors and get the right answer. My point is, we could expand this problem like we expanded this problem, but in that next step, whereas here it's all multiplication, here we've got to deal with that whole addition or subtraction of things inside. So we got to be careful with that. Doing this problem like this is the most common mistake. You've got to expand it and then FOIL it. All right, let's take a look at some more examples of how it does work. Let's say I have the quantity b minus 1 squared. So that is b minus 1 the quantity, times b minus 1, the quantity. Then we're going to FOIL those together. B times b is b squared. B times minus 1 is minus 1b. Minus 1 times b is minus 1b. And minus 1 times minus 1 is plus 1. B squared minus 2b plus 1, final answer. I want to mention something. I know I mentioned this before, but I don't think everybody got it. In WebAssign, it doesn't like, let's say you put a 1 here. Even though there's an implied 1 coefficient, it doesn't like having it there, and I think it tends to mark it wrong. So you want to be careful, even though technically there's a 1 coefficient there, don't put it there. All right.
Yeah, that tripped me up one assignment. It took me a bit to figure it out.
Yeah, and here's what I don't understand, okay? Some of you, you're not learning from the homework. And what I mean by that, and I'm not specifically talking about you, okay? But where I'll go through and it's like on the test, they put ones where they really shouldn't have, or in the graphing, they did the graphing wrong. But then I went back and I looked at the homework and the homework was all right. So it's like somehow they figured it out, but then they didn't transfer that knowledge to the test. So you've got to really be careful in how you do that. Pay attention to what you're doing. The homework is for practice for the test. Okay. Anyway, let's see here. Here is another example. We have, let's see, 9b minus 2, the quantity squared, which is 9b minus 2 times 9b minus 2. Okay. So then foiling it, we get 9b times 9b, which is 81b squared. 9b times minus 2 is minus 18b. Minus 2 times 9b is minus 18b. And minus 2 times minus 2 is plus 4. Combining like terms, we get 81b squared minus 36b plus 4. I call these pregnancy problems. Where in the world did I come up with that? Well, when a woman is pregnant, what does she do? She expands and then multiplies. Thank you for that courtesy laugh. And this is what we do. We expand it and then we multiply it out. Okay. All right. Let's see here. Y minus 5/3 the quantity squared. So we're going to expand it. Y minus 5/3 times y minus 5/3. And then we're going to multiply it all out. Y times y is y squared. Y times minus 5/3 is minus 5/3 y. Minus 5/3 times y is minus 5/3 y. And minus 5/3 times minus 5/3 is going to be plus 25/9. Because if you multiply fractions, you multiply the numerators and you multiply the denominators. Now, combining like terms, this is going to be nice because the denominators are already the same. So y squared minus 5/3 y minus another 5/3 y would be minus 10/3 y plus 25/9. And as I mentioned before, even though we could take negative 10/3 and make it into negative 3 1/3, leave it as a fraction. If you can reduce it, do so, but that doesn't reduce. Okay, any questions about that? Now, let's take a look at another kind of special product. Y plus 6 times y minus 6. Here, we don't start with two identical factors. We start with what is known as a conjugate pair. We've got a number plus the same number times a number minus the same number, okay? When we multiply those together, y squared minus 6y plus 6y minus 36, the two middle terms cancel each other out. And we're left with a binomial y squared minus 36. Let's take this general form a plus b times a minus b. We get a squared minus ab plus ab minus b squared. The two middle terms cancel out and we get a squared minus b squared. These answers are referred to as the difference, as in they're being subtracted, the difference of two squares. That's a square and that's a square. That's a square and that's a square. So when we multiply together a conjugate pair, what we get as an answer is the difference of two squares. Okay. Let's take a look at more examples there. 5t plus 4 times 5t minus 4. I have the sum of two numbers times the difference of the same two numbers in the same order. I'm going to get 25t squared minus 20t plus 20t minus 16. The two middle terms cancel out, and I've got 25t squared minus 16. Any question there? Okay, let's take a look at this one. M plus 4/5 times m minus 4/5. So I'm going to get m squared minus 4/5 m plus 4/5 m minus, now again, we're multiplying two fractions together. So 4 times 4 over 5 times 5, 16 over 25. The two middle terms cancel out. M squared minus 16/25. Mr. Mayo, I've got a question. Mr. Mayo. Yes, what? So if we recognize this as the difference of two squares, could we just go straight here and skip those middle terms? Absolutely, but make sure you've got that you're dealing with, okay? So for instance, let's see here. Let's take this problem. 2p plus 7, 2p minus 7. So that would be what? 4p squared minus 49. Okay? But just be careful that you don't shortcut something that doesn't belong there. This has to be conjugate paired. Okay? So just be careful of that. If you take shortcuts, you got to be careful. There are bears out in the woods. Okay. How about we throw in some decimals just for fun? 0.3 minus 2c squared, 0.3 plus 2c squared. Is this the difference of two squares? Yes. It's a conjugate pair. We can have the minus in front of the plus because remember, multiplication is commutative. So I'm going to get, let's see, 0.3 times 0.3. Be careful. That isn't going to be 9. What is that going to be? Let's see. That's going to be 0.09. Okay. So 0.09. And then I'm going to get what? Plus 0.3 times 2 would be what? 0.6c squared minus 0.6c squared. And then minus 4c to the fourth. Because again, those two middle terms would cancel out. Okay. Let's see here. Okay. Now we're going to expand it even further. We're going to have triplets instead of twins. Let's say we've got x plus 4 cubed. Again, this is not x cubed plus 4 cubed. That is wrong. This is x plus 4 times x plus 4 times x plus 4. We have 3 factors of the base. The exponent says how many factors of the base. So we've got 3 of them. So now I'm going to FOIL this together 2 factors at a time. All right. So I've got x squared plus 4x plus 4x plus 16, which is x squared plus 8x plus 16 times x plus 4. So now once I've simplified that first grouping, I'll expand or multiply that by the second one. So now I've got x cubed plus 4x squared plus 8x squared plus 32x plus 16x plus 64. Combining like terms, I've got x cubed plus 12x squared plus 48x plus 64. So I get this huge polynomial. Any questions there? All righty. Now, let's kind of do some mixing up here. Let's say I've got 2 times the quantity x squared plus 7x minus 1 minus 3 times the quantity x squared minus 2x plus 2. So here we're not really going to be doing that FOIL. We're going to distribute though. 2 times x squared is 2x squared. 2 times 7x would be plus 14x. 2 times minus 1 would be minus 2. We're going to distribute the minus 3. So we're going to get minus 3 times x squared, minus 3x squared. Minus 3 times minus 2x would be plus 6x. And minus 3 times plus 2 would be minus 6. But we're not multiplying the results together. These are all being added and subtracted now. Combining like terms, we're going to get negative x squared plus 20x minus 8. Any questions there? Okay, take a look at this one. 3x plus 4, 2x minus 2, minus 2x plus 1, x plus 3. Be careful of that sign right there. And we're going to talk about that when we get there. So let's, you know what? I want to go on to another problem for a minute. I'm going to come back to this. Let's say I had 8 times 6 minus 2 times 5. Okay. Order of operations, what would you do first? Would you do the multiplication or the subtraction?
Multiplication.
Multiplication. So this would be 48 minus 10, which is 38, right? Okay, now, so let's do the multiplication. We've got 6x squared minus 6x plus 8x minus 8 minus 2x squared plus 6x plus x plus 3. Combining like terms, I get 6x squared plus 2x minus 8 minus 2x squared plus 7x plus 3. Now, there's something wrong with what I've just written. What is it? Anybody? There's
Weren't
something.
you supposed to switch everything because there was a negative in front of it? To like since it would have been negative 2x and then the plus 1 it would have been negative 1, or am I wrong?
Okay. You're not wrong. Let me talk about that. You're right about dealing with that sign. We can, multiplication would come before subtraction. So we can multiply this all out before we distribute the subtraction sign. But what I needed to do was to have parentheses here because I haven't distributed the subtraction sign. Now, you could distribute it here through the first two, but I wouldn't advise it. People tend to mess it up when they do that. I would do the multiplication, just like here we did the multiplication first, and then apply that subtraction sign. So the thing that I failed to do, I put the parentheses here, but then I left them off here, and I did that on purpose to see what you do with it, but you need to keep them there, and then ultimately you're going to distribute the subtraction sign.
Okay.
Yeah, now, I could have left a set of parentheses there. I got away with it because since it's a plus sign or nothing in front, those parentheses aren't going to change things. So I didn't bother to put it there because I knew that I could just remove them. But if you're subtracting a product, you've got to subtract the whole product, okay? So then we get 4x squared minus 5x minus 11 as our final answer. But what'll happen is people will just go minus 2x squared, and then they'll have a plus and a plus where they should have distributed that subtraction sign. Okay, let's look at one more of those here. Let's say I've got this 5a minus 1, the quantity squared, minus the quantity a minus 8 times a plus 8. So first of all, I'm going to take the 5a minus 1 and expand it, okay, and multiply it. 25a squared minus 5a minus 5a plus 1, combining like terms, 25a squared minus 10a plus 1, okay? Then I'm going to take the second group and I'm going to multiply it out. A squared plus 8a minus 8a minus 64, but I need to quantify that. A squared minus 64. Okay, so again, I'm going to simplify that all down, and then I'm going to distribute the negative. So minus a squared minus times minus plus 64. Let's see if I can write that a little bit nicer. 25a squared minus 10a plus 1. So I get 24a squared minus 10a plus 65. Okay with that?
Yeah.
One more example. Let's say I've got negative 2h times 7h minus 2 squared. So exponents first. I've got negative 2h times the quantity 7h minus 2 times 7h minus 2. Now, I have a choice. Let's say I've got 6 times 3 times 2. Multiplication is commutative and associative. So I could multiply these two together first, or I can multiply those two together first. Okay, so same thing here. I can do those two first, or I can do those two first. But either way, be very careful. What do you want to do? Shall we do the first two first or the second two first? You tell me and we'll do it that way.
The second.
Okay, so I'm going to have negative 2h, and I'm going to do this. I'm going to get 49h squared minus 14h minus 14h plus 4. And then I'm going to combine like terms and get 49h squared minus 28h plus, come on, eraser, plus 4. So I've taken the 7h minus 2, the quantity squared, and broken it or expanded it out to that. Now I'll distribute negative 98h to h cubed plus 56h squared minus 8h. So that would be the final answer. Now, you've got to be careful because a common mistake, let's say that you elected to do these two first. I'll get people they'll distribute it here and here and here and here. And no, you don't do that. You just multiply those two factors together and then take the result and multiply that out. You don't distribute it across everything. Just like 6 times 3 times 2 is 6 times 3 times 2. It's not 6 times 3 and then 6 times 2. You don't do that, right? So be careful with that. The rules of arithmetic are the same as the rules of algebra. They don't suddenly change. Okay. So tonight you've got section 5.7. I'll be back at 1:15 with an office hour if you have any questions. Otherwise, have a great rest of the day. I'm going to stop the recording.